Good evening, everyone. Welcome to O-Level Physics second theory lesson on current of electricity. Today is Tuesday, 28th of March. My name is Mr. Chu. And before we begin, can both of you tell me what are the formulas that we learned so far last week? Okay, there's two main formula. So what are the two formula? But the two formula can exist in different forms. Okay, but there are two main formula that you need to know. So share with me on the chat. Okay, Hao Ming, well done. Wenxuan incorrect. Incorrect. And Wenxuan for current, the symbol is capital I. Hao Ming, your J is the unit, okay, it's not the correct symbol. J is the unit for work done. You are correct, but that is not the correct symbol. Okay, you write down work done instead of J. J is a unit, okay, not the symbol for work done. Okay, Wenxuan, well done. Okay, so we have learned two things last week. We have learned current as well as learn in primary school you learn voltage. Okay, but actually now we are actually learning not this one. We are learning PD or EMF. Okay, we are learning PD or EMF. Okay, so for current itself, okay, very good. Current is equal to the rate of charge, the flow of charge. Okay, that is the meaning of current. Okay, hold on for a while. Okay, then the other formula, if you want to rearrange and make Q the subject, okay, it will be Q equal to current times time. Okay, the charge is equal to current times time. Okay, so very good. Both of you are able to get this. Okay, the next thing is, okay, PD and EMF can be, you can actually write it in different manner. Okay, you can write down as PD, you can write down as EMF, or you can write down as volt, okay, voltage. Okay, so what's the formula of these three things? Okay, what's the formula of these three things? So for Wenxuan, can you share? Okay, how many can you rewrite? How many? Okay, not wrong. Okay, but we learned in previously, work done, we actually use the capital W will do. But capital W can be misleading lah. Not misleading lah, it can be also interpreted as weight. Okay, so WD is also not very good because it may looks like weight times density. Okay, so okay, so in this case, you can use work done divide by the charge. Okay, or you can use another one is the energy divide by charge. Okay, either one is fine. Okay, either one is fine. So this is the two formula that you learned last week. Okay, and this week you're gonna learn another two more. Okay, so for now, are you able to, okay, I want both of you to write down all the 4 formula that you see here, okay, in your chat, and then before we carry on. Wenxuan, you don't use the word E, use the word EMF. Okay, likewise, don't use the word P, just put PD. Okay, that will be the proper way. Okay, write down EMF or PD. Don't write down E. Small e actually doesn't represent EMF. Okay, Wenxuan, well done. Can you rewrite the EMF formula? Okay, for Hao Ming, can you rewrite the 3 formulas on the chat and show it to me before we continue? Okay, Wenxuan, that's much better. Okay, and to just emphasize further, let me go and write down the unit for you all. The unit for I is ampere. Okay, the unit for I is ampere. The unit for charge is coulomb. The unit for time is second. Okay, so basically ampere is also the same as coulomb per second. Okay, they are very similar. And I is a base unit. Okay, it's a basic unit lah. Is that clear? I is a basic unit. Okay, so Q is in coulomb. Okay, I is in ampere and time is in second. Okay? Okay, so all of these 3 down here, their unit are all volts. Okay, they are all volt. This is in joule and this is in coulomb. Okay, so you're convinced that volt is the same as joule divided by coulomb. Okay, this is in unit. Okay, what I written in red is in unit. Is that clear so far? Okay, those are written in red is in unit. Those are written in yellow is the formula. Okay, so now all of you are very clear about this, and let me continue. Okay, so last week we talked about last week we talked about hold on, let me find my okay, so last week we actually went through the difference between conventional current and electron flow. So everything that we do will be conventional current. Just be mindful that in actual fact, it is the electron that's flowing. But everything that we do, calculate, formula, is all conventional current. Okay, we talked about EMF and potential difference last week. So this week we'll be talking about resistance. Okay, so last week we mentioned A, B, C. Okay, y'all just take a minute to actually read through A to G. Let me go on my fan. Then we will continue with the last part called the resistance. Okay, so today we'll be talking about resistance. And resistance, there's a few parts. I can see there's so many parts about resistance. Okay, so today we'll be talking about all this. Okay, we'll be talking about the resistance. Okay, so for a start, the third formula, okay, that you all need to remember, okay, will be this. Resistance is the same as, okay, resistance is the potential difference divided by current. Okay, so this thing itself is exactly the same as this. R is equal to V divided by I. Okay, so this formula R equal to V divided by I is also the same as Ohm's law. Up to here, are you all clear? Okay, so Ohm's law actually is telling you that V and I are directly proportional. Okay, V and I are directly proportional. Clear so far? Okay, so up to here, any question? Okay, so I need you all to just memorize first. Resistance is actually voltage divided by current, or PD divided by current, or EMF divided by current. Okay, that's how you actually calculate the resistance. Okay, so in electricity, okay, current, we use ammeter to measure. Okay, so for EMF and PD, we use a voltmeter to measure. Okay, so for resistance, there's no resistor meter at all. Okay, so in O level, how do we measure resistance? Okay, we use the ammeter to measure the current. Okay, we use the ammeter to measure the current. Okay, measure the current. And you use the voltmeter to measure the PD or the voltage. And then you calculate the resistance. Are you clear about that? Okay, so resistance, there is no resistometer out there for you to measure. Okay, so for PD, okay, you use a voltmeter to measure. And then for current, you use an ammeter to measure. Okay, once you measure these two, you can actually calculate the resistance. Okay, and the relationship will be R equal to V divided by I. Okay, how to memorize this formula? So for me, not for me, my teacher, when I was a secondary 4 student, okay, he or she, yeah, she actually taught us how to memorize this formula. Okay, so she actually make V the subject. So can you all just type in the formula? You make V the subject, what would this formula be? Can you all type it out now? You make V the subject, and then what would this formula be? Okay, now type it out in the chat and show it to me. Okay, make V the subject. Okay, so from okay, Hao Ming, well done. Wen Xuan, your I is incorrect. Can you redo your I? Okay, Wen Xuan, your I shouldn't be a small letter. So what should, can you rewrite your formula? Okay, well done, Wen Xuan. Okay, so all of you that give me this value, V is equal to IR. If you look at most of the textbook, okay, they actually use this formula. Okay, they use this formula. Okay, however, this formula can be also rewritten in another manner. Okay, can I actually rewrite in this way? Okay, and this is the way my secondary 3 teacher teach me. Okay, how to memorize this formula? V will represent victory. Okay, and what is one of the top school in Singapore is RI. Okay, so okay, I'm not from RI by the way. Okay, but that is how I remember this. So can you imagine after so many years after school, up to today, I still remember what my teacher teach me because if it's memorable, easier to remember. Okay, so for my teacher, she teach me victory is equal to Raffles Institution. Okay, so V equal to RI, and that is how I remember till now. Okay, there's no need to actually go and understand. Just remember V equal RI, and that's how I remember this formula. Okay, so this is how I remember. If you look at textbook, a lot of textbook actually use V equal IR. Okay, but actually both formula are actually the same. Okay, but a lot of textbook represent it in the first way. Okay, so there's nothing wrong here. Okay, so for resistance, okay, the formula of resistance, you just need to remember V equal to RI, or if you prefer, you can also remember it as V equal IR, or even R equal V over I. Okay, these three are all the same. So you just choose the one that you prefer to remember. Is that clear? Okay, so what is the definition of resistance? Okay, what is the definition of resistance? So can you see down here? The definition is this formula. Okay, how do you write it in word? How do you write it in word? So you can write it down like this. Okay, resistance of a component is the ratio. Can you see this like the ratio? A divided by B. So it's ratio. Okay, ratio of the potential difference V across it to the current I flowing through it. Okay, so if I were to draw a simple diagram, okay, a simple circuit. So can you see here? Let this rectangle, this rectangle resistance to be, you want to find the resistance of this. So what is this resistance? Okay, this component. Okay, how do you find the resistance of this component that I highlight in blue? Okay, it's basically the ratio of the potential difference. So how do I find potential difference? I put a voltmeter. Okay, I put a voltmeter across it. Okay, so I actually find the difference of the potential between the before and after that point. Okay, the 2 points before and after the component. So I put a potential, a voltmeter across the component. Then I also put an ammeter that measure the current that flow through the component. So once you have the value of V and once you have the value of I, okay, so you're able to find the resistance, which will be V over I. Okay, that is how you actually calculate the resistance of a component. Is that clear? Is that clear? Okay, if you are clear, give me a thumbs up. Okay, well done. Okay, let me continue. So there are a few things about this. Okay, the unit for PD is volt. The unit for ampere, for current is ampere. So can you tell me what is the unit for resistance? Can you tell me what is the unit for resistance? Okay, so now I'm actually talking about J. Okay, how do I actually calculate the resistance of a conductor? So this is what I'm doing here. Okay, you set up like this. You put a voltmeter across it. Then you put the ammeter through it. Okay, and then you're able to find you use this formula, you're able to find the resistance. Okay, who write this green color one here? Who is this? Why I cannot press? Hao Ming. Okay, very good. So the unit for resistance is called ohm. Okay, the symbol is like this. Okay, this is the symbol. The pronunciation is called ohm. Okay, so far? Okay, so that's how you actually calculate the resistance of every metallic conductor in a circuit. Okay, to find the resistance, okay, of this metallic conductor, we just need to put a voltmeter across it. and then put an ammeter through it, okay, and then use this formula, you're able to calculate the resistance of this metallic conductor. Is that clear? Can? Okay, if this is okay, please give me a thumbs up. Okay, so let's study this formula. Okay, let's study this formula in red. Okay, let's study this formula. How do you tell when the resistance is high? Can you see this? If you require a big potential difference, okay, previously you all know that potential difference is work done over unit of charge. Okay, so if let's say the current is the same, okay, two components, they have the same current flowing through it. But the first component, the first metallic conductor, require a bigger V for it to go through. So you have a greater resistance, correct? So a bigger V with the same I will have a greater resistance. What does this mean? Okay, a greater voltage or greater PD means it requires more work to push one unit of charge across the conductor or the component. Is that clear? So if the V is high and the current is the same, okay, your resistance is higher because you need to push in more work for every charge of every unit charge, okay, to push the current through the resistor. Okay, sorry, through the conductor. So therefore, the resistance is higher. Okay, are you able to appreciate my understanding, my explanation? Are you able to appreciate and understand this now? If you can understand, give me a yes reaction. Will you understand? How many are you confused? Or you need me to repeat? Your thumbs up is here. Okay, then can you look at this formula again? If the PD is the same, okay, if the PD is the same, is it possible to be the same? You look at this diagram. Okay, this diagram. If I have one more resistor through it, can? You have one more resistance through it. Okay, so this battery provide a fixed EMF. Okay, let's say I give it a 10 volt. So this battery provide 10 volt of EMF. What does EMF means? EMF means 10 joules of work, okay, per unit charge supply. Is that clear? Okay, so it provide 10 joule of energy for every unit of charge that flows through the whole circuit. Okay, so that's what the battery does. Okay, so if the battery were to provide 10 volt, before the battery is 0 volt. After the battery, it will increase to 10 volt. So these are the potential. Okay, this point is the potential. The potential of this point is 0 volt. The potential of this point is 10 volt. Okay, if there's nothing along the wire, and we assume the wire has no resistance, so the whole wire here with nothing will all be 10 volt. Okay, so let me just highlight. If I were to highlight in green, so are you convinced that the part here will all be 10 volt? Because there's no resistors in between. Clear so far? Then the part here will all be 0 volt because there's no resistor in between to take up the energy. Okay, so everything along the green is 10 volt. Everything along the orange is 0 volt. So if I were to measure the potential difference across this component, this V should also show me 10 volt. If I use the same voltmeter to measure the difference between the center component, the one in white, it will also show me 10 volt. Clear so far? Clear so far? Okay, if you are clear about this, give me a yes reaction. Okay, when she asked me to repeat, okay, how about like this? Let me draw bigger. Hey, is my voice very loud? Do you all actually reduce the volume? Because my Apple Watch tell me the surrounding very loud. Must be my voice very loud. Okay, let me. Okay, so let me just redraw again. Yeah, maybe I don't use resistor. I use light bulb. I use light bulb. Okay, so let's look at this circuit in parallel. Okay, parallel. Before the battery, okay, the battery, this part is the longer one is a plus, the shorter one is a minus. Okay, no need to write, but I'm just showing you. The longer one is plus, the shorter one is minus. Okay, so if there's no battery, right? If there's no battery, the potential here, those that I'm going to highlight in green. Okay, so the potential throughout here, because we are assuming that all this wire has no resistance. We are assuming that there's no resistance. If I were to measure the potential here, it will all show 0 volt. Okay, so everything along the green color path will all be 0 volt. Up to here, any question? Okay, Wenxuan, are you clear about this? Okay, anything that's along the green color, there's no component here, right? There's no resistor, there's no bulb, there's no nothing at all. It's just wire. Okay, Wenxuan asked why 0 volt. If there's nothing, it's 0. If let's say I got no battery here, there's no battery here, so the wire will all be 0 volt. Okay, so just assume now that just take it as there's no battery, there's nothing here at all. A normal wire will all be 0 volt. And the normal wire, when they don't connect to anything, there's nothing in between. We will still have the same potential with 0 volt. So everything along this green line, okay, the wire that's in green will all be 0 volt because there's nothing in between. There's no other component. Okay, so if this point on top here, if it's 0, the rest of this wire will also be 0. Clear so far? Okay, so now we talk about this battery. This battery increase the potential. So this is the potential here is 0, right? Okay, the potential here is 0. Okay, the potential here is 0. This electrical source or the battery will raise the potential by whatever EMF it is. Okay, so a popular AA battery that we like to use often has a EMF of 1.5 volt. Okay, so what does this mean? This means that the battery here will raise the potential or increase the potential by 1.5 volt. So before the battery, it is 0. Can you see 0? Then after the battery, if I were to measure this point, it will be 1.5 volt. Up to here, are both of y'all clear? The battery raise the EMF or the potential by 1.5 volt. Wenxuan, is it okay for you? Okay, so everything along let me draw. So everything after the battery, if there's no other component in it, Okay, the orange part. Okay, wait, I draw wrongly. Okay, the orange part will all have the same potential because there is no other component or no other battery source to change the potential. Okay, so everything along the orange line will be 1.5 volt. Clear so far? Can? So, if I were to measure the difference between these 2 points, if I put a voltmeter here, you have to measure the difference between the orange line and the green line. My voltmeter will shows me 1.5 because green is 0, orange is 1.5. So the EMF across this battery, this voltmeter will shows me 1.5. Clear so far? Okay, all because this point is 1.5 volt and this point is 0 volt. Okay, Ken, same thing. If I were to put a voltmeter across the first light bulb, this point is still orange, right? It's still 1.5 volt. This point is 0 volt. So this itself will shows me 1.5 volt. Is that clear? If I were to put a voltmeter across the first bulb, my voltmeter will shows me 1.5 volt. Is this concept clear to you? So basically what's happening here? The battery raised the potential by a value of 1.5 volt to become 1.5. If let's say the green color part here is not 0 but 10 volt, the battery will raise the 10 volt by 1.5 to here to become 11.5. Are you clear about this? So basically the battery raised the potential by the EMF of 1.5 volt. Then what does this PD means? This light bulb, okay, reduces the potential from 1.5 to 0. So the light bulb reduce the potential by 1.5 volt. Understand so far? Okay, so Hao Ming and Wenxuan, if you are clear about what I say so far, please give me a yes reaction. Okay, thank you, Wenxuan. Hao Ming, you okay? Hey, why your this thumbs out here? Okay, same thing for the bottom light bulb. If I were to put a voltmeter across it, okay, because the orange point is 1.5 volt and the green point is 0 volt, my this voltmeter will show me 1.5 volt. Clear so far? Okay, if you are okay, give me a yes reaction. Okay, so let's review the formula. Okay, let's review the formula. Resistance is equal to voltage over current. Correct? Let's review the formula. So now, let's look at these two light bulbs. The first light bulb, I let it be light bulb A. The second light bulb will be light bulb B. Clear? So, if you look at this formula, hold on. Okay, look at this formula. For these two light bulb, which one is the same? The R, the V, or the I? For these two light bulb. So far, based on what you draw here, what is the same for both? Is it the resistance the same, the PD the same, or the current the same? So based on what I draw so far, which one are the same? Okay, Wen Xuan, well done. How many incorrect? Okay, so can you see here? Which is the same? I already drawn here already. I'll take a look. Okay, can you see this? This is the same. Correct? Okay, so this is the same. So now, if I were to put a n meter at these two lines, okay, n meter at these two, if the first one has a higher current, the second one has a lower current, okay, because they have the same V, right? Which one has a higher resistance, A or B? How many say B? How about Wen Xuan? Which one will have a higher resistance? Okay, so are you all convinced? Because they have the same V. And the one that has lower current passing through it, you have a lower current passing through it, your resistance will be higher. Does it make sense to you? When you have less current flowing through the component has a higher resistance. Does it make sense to you? Okay, so far am I putting all the pieces together? I'm not trying to make you all memorize different things. I just want to understand the whole picture. Once you understand the whole picture, there's nothing much to memorize. What is V again? V is potential difference. Or if you use a primary school way is called voltage. Okay, it's called voltage. Okay, so can you see here this V? This is the voltmeter. It gives you a potential difference of 1.5 volt. And then the bottom one, this is the voltmeter. You also give me a potential difference of 1.5 volt. Wenxuan, are you okay? Hey, Wenxuan, are you okay? Okay, so let me just continue. If this ammeter give me a current, the value of 2 volt, are you able to calculate what is the resistance of this bulb or bulb B? Anyone? Okay, so if you use this formula, R is equal to 1.5 volt over 2 ampere. Okay, you will get 0.75 ohm. Okay, so my this resistance B is 0.75 ohm. Okay, what if this ammeter here give me a value of 4 ampere, a greater current. Okay, so both of you are convinced if the current is higher, this one should be less resistance, right? Okay, so based on this calculation, can you go and calculate what is the resistance of the bulb B, the bulb A? You want to do that? Hello. Wen, what's the formula here? On top is V or I? The numerator is V or I? Okay, the numerator here, is it V or I? And the I is below. So is your formula correct? Okay, can you try again? And then your value now here, 267 is greater than 0.75. So does it make sense? This has a greater resistance, and then it's a smaller resistance, but a greater resistance has greater current. Does it make sense to you? Okay, so you redo again. Okay, so can you see based on this will be 0.38 ohm. Okay, for example. So can you see here, based on this formula, you can tell that if the resistance is lower, okay, the resistance is lower, the current will be higher, given the same PD. Is that clear so far? Is that clear so far? Okay, so this ammeter measure how much current flowing through this line. This ammeter below here measure how much current measure flowing through this. So let me just write down this IB is equal to 2 ampere. This IA is equal to 4 ampere. So if I were to put an ammeter here, what would be the value of this? I total. So what can you tell me what would be the current here for this point if I put ammeter here? Current is I, V is the PD. Hello, if you are not sure how to find the total current, tell me in the chat that you're not sure. If not, can you guess or try or attempt what will be the total current here? Okay, Hao Ming, you are correct, but do you know why? Okay, let me erase this thing. Let me create some space. Okay, so I got two paths here. Okay, I got two paths here. They'll combine to go to this path. If the first path has 4 ampere, second path, okay, this is very ugly. Let me redraw. Okay, this is intersection, this dot. If the first path here has 4 ampere of current, the second path here has 2 ampere of current, which you can see over this point and this point, correct? So when they combine together, okay, and they'll combine together, so this current here, okay, okay, this current here will add these two current together, will give you 6 ampere. So for this total current, it will be 6 ampere because the 4 ampere contribute and the 2 ampere contribute come together to this point, total will be 6 ampere. Is that clear? Make sense? Understand? Okay, so now this is a parallel circuit. So let me summarize a parallel circuit. PARA, parallel circuit. For parallel circuit, if the two components are in parallel, the voltage is the same. Okay, don't use the voltage. The PD are the same. Is that clear? If the two components are in the same parallel, their PD are the same. Can? Then the total current will be equal to current A plus current B. Okay, so the total current will be equal to current A or current B. Okay, so let me write this down in another way. So V1 equal to, okay, the EMF equal to PD1 equal to PD2. Okay, so the EMF in each, these three are in parallel. The EMF is equal to the PD of the first component plus the PD of the second component. Clear? Then the total resistance, this one, the total resistance here, will be equal to the total, the total current I will be equal to the I of A plus I of B. Write down A and B. Okay, A and B. Is that clear? Now, we have these two resistance. One is 0.38 ohm. The other one is 0.75 ohm. What would be the total resistance here? So for parallel, how do we find the total resistance? Okay, there's a few ways. Let me do the easy way first. Okay, let me do an easy way first. Let me erase this. Okay, so far for these two, EMF, they are all the same. Are you clear? Are you clear about this? Okay, then the total current is equal to IA plus IB. Are you clear about this? These two are you very clear? If you are very clear, give me a thumbs up. If you are very clear, give me a thumbs up. How many? You okay? All right. Now, you know that the total current is 6. Okay, I'm going to highlight the important part. You know that the total current is 6. You know that the EMF is 1.5. Okay, so can I find the total resistance is equal to the total EMF divided by the total current? So can all of you do that now? Can you find what is the total resistance? Okay, the total EMF is 1.5 volt. The total current is 6 ampere. So what is the total resistance here? Okay, so let me write down the answer for you. EMF is 1.5 volt. The total resistance is 6. The total ampere is 6 ampere. Total current is 6 ampere. So what's the answer for this? 0.25 ampere. Both of you able to get this answer? Hello? Are both of you able to get 0.25 ampere? Okay, Wenxuan, you got it. How about Hao Ming? Okay, so you see here, the total resistance is 0.25. The first resistance is 0.38. The second resistance is 0.75. So when you put two resistors together in parallel, your final total resistance is actually lower. Is that clear? Okay, why so? Imagine you are the current. Okay, you are the current. There are 6 ampere of you. When you reach this point, okay, when you reach this point, you have two decisions to go. You can go by the route A or go by the route B. Because A has a lower resistance, more of the 6 of you will go by the route A than the route B. Is that clear? So therefore, A has a higher current than B. Okay, because A, the resistance of A is lower than the resistance of B. Okay, so why is the total resistance even lower? Okay, can you just imagine? Just imagine this is 0.38. Just imagine this is a obstacle with a diameter of 0.38. That's right. With a very big diameter, means a lot of people can go through. The resistance is low. Whereas for this, the obstacle is actually longer. Okay, sorry, let me repeat. The first obstacle A here is 38 meter long. So you must go through 38 meter obstacle. The obstacle B here is 75 meter long. So this obstacle is much longer. Is that clear? Now, when you have two obstacles in front of you, there's actually two paths. When it's just by one obstacle alone, it's harder to go through. But when you got two choices, there's more option for you. So the total resistance in parallel will be lower, 0.25. Are you clear about this? Hey, I think I'm confusing you already. So basically, if I were to draw like this, these two are the same. Hey, wait. Okay, these two are the same. If this is 0.75 ohm and this is 0.38 ohm, okay, and this thing itself, when you combine together, it will become 0.25 ohm. Okay, both of them are the same. Okay, both of them are the same. Why? Okay, because this is 1.5 volt, this also 1.5 volt. Clear? The current, in this case, 6 ampere. The current is also 6 ampere. So we use the formula V equal to Ri, the one that I always remember. They'll both give the same result. Can? So 1.5 volt. Do you find the current going through this? You have to find the current going through this. Current is V over R. So 1.5 divided by R, you will get 4 volt here. Like 4 ampere here. Okay, 1.5 volt divided by 0.75, you will get 2 ampere here. So when these two add together, you will get 6 ampere. Okay, so these two are equivalent. Clear so far? These two are equivalent. So I let this be R1 and R2, and this is R total. Okay, so what is the formula between the three R? Okay, so how do you find the formula? 1 over RT is the same as 1 over R1 plus 1 over R2. Okay, so this is a formula that all of you need to remember for parallel. Okay, so for parallel, first of all, in this case, V1 equal to V2 equal to the total V. Okay, this is the total V. Okay, next thing, I1 plus I2 equal to the total I. And then the resistance, if it's in parallel, how are they related? It is like this. 1 over R1 plus 1 over R2 will give you 1 over RT. Okay, if you all don't believe, you all sub in. I let my R1 equal to 0.38. I let my R2 equal to 0.75. Do you actually get 1 over 0.25? Okay, can both of you go and calculate? Okay, I want you all to be convinced that this formula is true. Can you all do that now? Wenshen, when you put that in the decimal, you should get about 4, right? Okay, the reason why it's not very accurate because I round up lah. Okay, in this case you use 0.375, you should get the more correct answer. Okay, Wenshen, try again. How many are you okay? Okay, so now we have a study in depth on a parallel circuit. Yeah, I do not know why I started parallel circuit. Okay, because series will be easier. Okay, let me continue. So now we go the same thing. Now I put these two in series. Okay, in series. Okay, let's study this together. If my this battery is the same, 1.5 volt. Okay, 1.5 volt. Let me show you. The part that I highlight in this funny color, brown color, right, is all 0 volt. Okay, the part that I highlight in green here is all 1.5 volt. Why? Because this battery raise the potential from 0 volt to 1.5 volt to the left side. Can? Okay, so this 1.5 volt is between the green point and the brown point. Okay, let's wait for a while. How many just went out? So let me pause the recording. Okay, so can you see in the brown highlighted wire, it is 0 volt. The green wire is 1.5 volt because the battery raised the potential from 0 by 1.5 volt to become 1.5 volt. It raised up the potential by 1.5 volt. Clear so far? Okay, how many you put here 0.75 is assuming that the resistance of these two are the same. Okay, you are assuming that these two are the same. And let's assume they are the same. Okay, let's assume they are the same. But before we do that, are you all convinced that I1 here and I2 here? Okay, so in a series circuit, I1 is equal to I2 because there's only one path. There's no multiple path. So the current will be the same throughout. Are you convinced about that? Okay, Wenxuan, your Y is for what? Okay, why are they equal? Okay, for the current, it's just like there are 10 of you running around the track. Okay, so there's only one way to run. So whether you're on the left side or on the right side, there are just 10 of you. Okay, there's only 10 of you have only one way to run. Is that clear? Whereas in a parallel circuit, okay, if there are 10 of you here, when you reach a junction, okay, you can split up. Maybe 2% will go to the first path, 8% go second path. Then when the 2 and 8 of you come together, the 10 of you will run the rest of the path together. Is that clear? Current doesn't reduce when you go through a path. Your current shouldn't reduce. Okay, the thing that reduce is the PD. It's not the current that reduce. So if there are 10 of you running around the track, the 10 of you will continue to run. Remember, your current is like your electrons moving around in a circle. Is the current is the electron. It's the electron that is moving. Clear? How many say what alien technology? Okay, so the electrons is moving in the opposite direction. Okay, the electron moving in the opposite direction. So if there is 100 electron moving, you all move in one round. The 100 electron move in one round. You will not disappear. Okay, that is what current means. So if there are 10 of you running, there are 10 ampere of current on the left side, the current will not reduce. The whole circuit will have the same current. Is that clear? So the resistance, yes, the resistance affect the value of the current, but it doesn't make I2 lower than I1. The greater the resistance, the lower the current, but I1 and I2 should be the same. Did I make it clearer for you now, Wen-Shen? Okay, the keyword here is the same. Yes, if the resistance is high, this I value becomes smaller. But I1, the smaller I1 will be the same as the smaller I2. So I1 will be the same as I2. Understand so far? Get it? Okay, but in the parallel circuit, the I itself, once it reaches the intersection, some will go to one way, the other one will go to the other way. But the sum of these two paths should be the same as the total current. Clear? Okay, so let's continue. In a series circuit, let me not go into calculation. I will do calculation next week. In a series circuit, the total resistance is equal to the resistance 1 plus resistance 2. If this is 5 ohm and this is 6 ohm, the total resistance will be 5 plus 6 equal to 11 ohm. Is that clear? Is that clear? Are you clear about this? Same thing for V, the total V, let this be the total V, will be equal to V1 plus V2. So this is V1 and this is V2. Okay, so the total V will be equal to the V of 1 plus the V of 2. So if this is 1.5 volt, if we reduce here by 1 volt, you leave with only 0.5 volt. Then the V2 will be 0.5 volt. Are you clear about this? Okay, so now up to here, any question for me? Okay, maybe let me summarize. Series and parallel. Okay, let me just draw a sample. Okay, let this be 1. And let this be 1, this be 2, this is B1, this be 2. Okay, so when you talk about series, okay, current 1, let this be S, the source. Okay, the current on the source is equal to current 1 and current 2. Is that clear? Okay, because there's only one path, all the current are the same. Then for parallel, okay, the current from the source will be equal to current 1 plus current 2. Okay, because the source here, it reach this intersection, it can go by 1 and go by 2. So you add 1 and 2 together, it should be all the current by the source. Clear so far? Now, how about this? V at the source is equal to V1 plus V2. Okay, so if the EMF increase the potential by 10, okay, 1 can reduce the potential by 5, then 2 will reduce the potential by the other 5. Okay, so the S will step up your potential, whereas your 1 and 2 will both step down. Then in parallel, in this case, for parallel, the V of S is the same as V1 and equal to the same as V2. Because on the left side, they are all the same. On the right side, they are all the same. So the difference between the left and right for all three are the same. So therefore, the difference is the same. Clear? Then for resistance, total resistance in this case is just R1 plus R2. I just add R1 plus R2 to get the total resistance. Whereas for parallel, 1 over total resistance is equal to 1 over R1 plus 1 over R2. If there's 3 paths, there'll be 1 over R3. Just add on more. Okay, so this is a summary of what we learned today. Okay, and on top of that, you also need to know V is equal to Ri. Okay, so this is the whole big summary of what I went through today. Clear so far? Are you all confused? Okay, if today's lesson is okay, give me a yes reaction. Okay, thank you. Hao Ming. Wenxuan, are you okay or not? If you're not okay, can you read through your textbook and then read through my this video one more time? Okay so far? Okay, so that is the whole summary of the main thing that we learned today. But there's 2 more things that we need to go through. Okay, there's 2 more things we need to go through. So let's go back to the slides. Okay, so I have went through. Okay, so today we need to go through all this. I went through this, I went through this, I went through this, and this. Okay, and a bit of this. Okay, so the last few minutes, I'm going to go through L, N, and O. Okay, so let me ask you a question. If your obstacle course, okay, your obstacle course, the longer you need to go through an obstacle versus the obstacle is shorter, which one is actually more difficult to survive? The long obstacle course or the short obstacle course? Okay, for example, I ask you to race 1 kilometer versus 10 meter. Which one is more tiring? The 1 kilometer race or the 10 meter race? Which one is more tiring? Okay, Wenxuan say 1 kilometer. How about for Hao Ming? Hao Ming is even worse, 10 kilometer. Okay, so are you all convinced the resistance is proportional to length? The longer the resistor, the greater the resistance. Are you all agree with that? Okay, now I'm going to go through obstacle A and obstacle B. Okay, this is the area. Now I want you to go through the hole. A smaller hole is easier to go through, or the bigger hole is easier to go through? Can you tell me? What did you say bigger? Okay, so easier to go through the big hole, right? So are you convinced also that resistance is proportional to 1 over area? The bigger the area, the lower the resistance. The smaller the area, the greater the resistance. Are you all agree? Are you all agree with this? Can So if I combine these 2 things, can I say that resistance is proportional to length over area? Make sense? Make sense? Can you all remember? Okay, the longer the length, the greater the resistance. The bigger the area, the smaller the resistance. Okay, this relationship, can you all remember? This is Sec 2 max, direct proportion. So, next thing, okay, I'm going to revise Sec 2 max, with you all. If y is proportional to x, okay, if y is proportional to x, can I rewrite this as the relationship will become y equal to kx? Do you all remember this before? K is a constant or your gradient. Okay, so y is equal to kx. If y is proportional to x. So when x go up, y go up by a factor of k. If x goes down, y will go down by the same factor of k. Is that clear? So basically, if I were to draw a y-x graph, it will be a straight line cutting through 0, where the gradient is k. Are y'all convinced by this? Can So I let the y be the R. I let the x be the L over A. Are y'all convinced that the new formula can be like this? Can? Are y'all clear about this? So if I were to draw resistance over length over area, it should be a straight line. Clear so far? It should be a straight line. Now, this k is a constant. This k is a constant. Okay, and this k in this topic in physics, we call this resistivity. Okay, this resistivity, we have a symbol for it. We call it rho, something like density rho. Okay, so the formula end up become resistance is equal to rho L over A, where the rho is the resistivity of the material. Okay, so different material like iron have different resistivity. Okay, a copper has a different value. Okay, a gold has a different value. So this value is fixed for a material. Is that clear? Okay, it's a constant for the same material. Okay, so basically this formula tells you that the longer the length, the greater the resistance. The greater the area, the cross-sectional area of the wire, the smaller the resistance. Understand so far? So can you all remember this? If you all can remember, give me yes reaction. Then we go through the example, then we will know, then you will able to know what I'm trying to say. Okay, are you all right? Okay, so if you are okay, so we have went through number L. Okay, now we go to N. How does temperature affect the resistance of a metal conductor? So let's say the temperature increase. Do you think the resistance increase or decrease? Can you make a guess? If the temperature of a metal increase, would the resistance increase or decrease? Okay, Wenxuan say increase. How about for Hao Ming? What's your guess? Why is it the higher temperature increase then? How about for Hao Ming? Do you think it increase or decrease? Okay, so let me share with you the answer. When the temperature increase, does your particles of the metal vibrate faster or slower? Okay, first can you tell me, when the temperature increase, does your particles vibrate faster or slower? Faster. Okay, so imagine there are 10 people in the room. Okay, 10 people in the room. First room, they are all walking slowly. And you need to walk through the room from one end to the other end. Then there's a second room. Same, 10 people, but they are all running. Which one do you think is easier for you to walk from one end to the other room? The one where the people are just walking, or the one where people are all running? Okay, Wen Xuan say if you are walking, it's easier to walk through lah. If running, then chance of hitting the person is higher. Am I right? How many do you agree with Wen Xuan? Okay, so when the temperature increase, the particles actually vibrate faster, vibrate more. So when it vibrate more, your electrons, the chance of electrons colliding with the vibrating particles will go up. Is that correct? So when your electron is trying to move from one place to the other, but it get hit by the particles, so therefore it's harder to move across. Your resistance will go up. Understand? Okay, so just remember when your temperature of your wire or your metal increases, the resistance of the metal should also increase. But it is not directly proportional. Okay, what is the relationship like? If the resistance and the temperature, okay, normally it should be a linear reaction. Okay, well, I call this relationship linear. Okay, why is it not directly proportional? Because the line doesn't cut through zero. If a straight line cut through zero, it is called directly proportional. But if it's a straight line only and doesn't cut through zero, okay, the relationship is called linear relationship. Can you remember this? It's very important for your physics practical. When you plot your graph, your straight line, your graph is a straight line, and if it cut through zero, these two are directly proportional. But if it doesn't cut through zero, but it's still a straight line, it means that these two variables are linearly related. Clear so far? Okay, the last part that I'm going to go through, let me show you the notes. Then before we end today, the last part. Okay, let me just show you on. Okay, so these are some of the symbols that you all need to go through. Can you take a screenshot? Next week I test you all. Okay, so I'm going to go through this thing called the diode. Okay, soon review the last part of today. Okay, let's continue. Okay, so let's continue. Okay, here. Okay, so we have learned that. We have learned this. R is V over I. Is that clear? And resistance is supposed to be constant at the same temperature. It doesn't change. Okay, so can I say that V is directly proportional to I? So if I were to plot a VI graph, it should be a straight line cutting through zero. Because it's I over V, okay? The gradient here is 1 over R. If it's V over I, the gradient will be R. Understand? Understand? Okay, so in this case, it's I over V. I over V is reverse, it should be 1 over R. So this gradient here is 1 over R. If I were to plot, okay, let me explain again. If I were to plot V over I, it will be the same straight line. The gradient here will be R instead. Understand? Okay, you all remember y equal to mx plus c or y equal to kx. In this case, if my v is equal to ri, okay, your v is your y, your I is your x, your r is your m or your gradient. Is that clear? Can? But if I were to draw I over v, my gradient will be 1 over r. Clear so far? Okay, same thing now. I draw I over v again. Okay, so the gradient will be like this. The gradient will be like this. Can you see? The gradient is decreasing. And the gradient means what? 1 over r decreasing is the same as resistance increasing. Clear so far? Can you see over here? The gradient actually is 1 over r. So as the gradient decreases, 1 over r decreases, it actually means that your resistance increases. Clear so far? Can? Lastly, if we talk about a diode means I got one, if I draw a diode, it looks like this. Okay, it means that you only allow current to move in this direction. Okay, in the opposite direction, the current will not move. Clear? So in the diode, you only move in this direction. In this direction, there will be no current. Clear so far? Okay, so this is the character. This is the drawing of how a IV graph of a diode looks like. Understand? So in this case, as you can see, if the voltage increase, the current increase. You'll be almost like a straight line, but it's a bit of curve. So when there is a voltage increase in one direction, there will be current flowing through. But in the opposite direction, can you see? The current is 0 or very low. But on the other direction, the current keep on going up. Can you see that? Okay, so that is a diode. A very interesting device. We'll go through that in practice next week. Up to now, did I make you all very confused in today's lesson? Okay, if you are okay, give me a yes reaction. If you're not okay, give me a no reaction. Then you all got no reaction. Okay, so those who are confused, it's fine to be confused. But Wenxian, can you take time to go and read through your textbook one time? Number two, look through the video one more time. Okay? Can? Then next week, clarify with me your confusion. Okay, I already sent the notes to you all. It's only just 3 pages. This note is only 1 page, 2 page, 3 page only. Go and read through the notes. Okay, if you want to see in detail, you all got textbook, right? You all got textbook or not? Is this your textbook? Similar or not? Okay, you all got textbook, look through your textbook. Okay, read through your textbook, then you watch the video one more time. Can? Do that before we go to practice next week. Because if you are still confused and go through practice, you'll be wasting more time. So can you take some time, read through your textbook or your notes, then watch the video at fast speed one more time, then write down the question you still don't understand. Next week, ask me the question before you go to practice. Is that clear? Can. So before we go, the same three, okay, wait. First of all, give me the formula of Ohm's law. Okay, one thing other than Ohm's law you will learn today. Okay, how much you learn today? 1 to 10. How well Mr. Chu teach today? Okay, give me your response. Once you're okay, I call your name, you may leave. If you got more questions, you can stay back. Okay, well done. How many for question one? How about two, three, four? Okay, both of you can go now. Thank you so much. Good night. Goodbye. See you all next week.